Hi everyone, thanks for joining me today. I'm Deepak and I'm going to be explaining about my DBMS project that I did for this subject in my college. So let's dive right in. This project is titled the Online Bookstore Management System. This project was all about building a robust database system using Oracle SQL and integrating it with Python for seamless data handling. My goal was to create a system that could manage everything you find in an online bookstore, like authors, publishers, customers, orders, and reviews. Today, I'm going to walk you through how I designed the database, inserted the data, executed advanced queries, and solved any challenges that came up along the way. So, let's dive right in with the scenario explanation first. So this project is an online bookstore management. What does an online bookstore need? The online bookstore may basically need books, authors, publishers, customers, their orders, and reviews. So these are the basic building blocks of the database for this online bookstore management system. Now, each book can be associated with multiple genres and linked to a specific author and publisher. Customers can place orders for one or more books and leave reviews with ratings and comments. So we have to store this ratings and reviews under somewhere and so as to retrieve them and then use them in the database system. Okay, this system ties everything together so all these relationships are easy to manage and query. And now let's talk about the ER diagrams and types of relationships in this particular online bookstore management system. Okay, so there are several entities, as I said before: the book, author, publisher, customer, order, and review. So talking about the types of relationships present in this particular DB system, there are one-to-many relationship. This type is represented between the author and book, as one author can write multiple books, but each book has only one primary author. We also see this between the publisher and the book, where one publisher can publish many books, but each book has only one publisher. And then there is the many to many relationship. This many to many relationship between order and book is many to many because each order can include multiple books and each book can appear in multiple orders. So this is a very common scenario that we'll be handling if this database, the online bookstore management system, is put in a e-commerce website or somewhere else. This order and book will be very helpful when it is a many-to-many relationship. This type of relationship requires a junction table. Since this is a many-to-many relationship, we have to take the primary keys from both the schema tables, and then reference it in one relationship table. So this will be helpful um, in managing and data retrieval. In this case, uh, the includes table. We are introducing a table called includes table, which will be holding the order ID and the ISBN with a quantity and attribute. And then the weak relationship. This relationship is called weak because it not necessarily has a primary key attribute. So the relationship between review and book can be considered a weak relationship, as a review depends on both a customer and the book they are reviewing. The review table has foreign keys to both customers and book tables. So this is a weak relationship. And then the total participation. This total participation means that every entity, every row in that particular um, scheme in that entity is related to has a mapping to other table. The order entity fully participates in the includes relationship. This includes relationship is the junction table that we created to the many to many relationship of order and book. Okay, so meaning an order must include at least one book. These relationships establish how data flows between entities and ensure that we can represent complex queries and interactions. Now let's take a look about into the ER diagram. So here you see the book entity. This book entity has several attributes like the ISBN. This ISBN is the primary key attribute in this particular um, entity. Okay, and then it has a title, it has a genre, it has sales, price, and year. So this will summarize about everything we need to know about the book in this particular table. Now moving on to the author table. This author has author ID and name. This in this table, author ID is the primary key attribute, and name, like as the name suggests, it is the name of the author. And then moving on to the publisher table. This publisher table has several entities like publisher ID, name, and address, which is a composite attribute, which has several sub entities like street, city, state, and then the zip code. Okay, so this publisher has prime PID as its primary key attribute. And then moving on to the order table. Order table has order ID, and then the amount, and then the order date. In this, the order ID works as the primary key. And then moving on to the review. As I said before, this review is the weak entity, and has ratings and comments, which will be saved for every book and for every purchase that is being made. And then finally, the customer. The customer table has customer ID and then the customer's name, which are the only things that will matter to us while managing the online bookstore. Okay, now moving on to the relationships. There are four relationships per se here: the rights, the publishers, the reviews, and then the buys. Okay. Buys or places. I'm sorry, it's places. Okay, so the places is the relationship between the order table and then the customer table, since customer places the order, so that's why it's named so. And then the review. You may have a question why this review has two say double border unlike the other relations. This is because the reviews is a weak relationship, and then to mention that we are having double borders for that. This reviews is a relationship between the book and the review. And then moving on, the rights relationship. This is between the book and author. And then the rights relationship is not a weak relationship, therefore it has a single border. And then the publisher's relationship. This publisher's relationship is between book and the publisher. Okay, now that's about it about the entity relationship diagram and the types of relationship present. Now let's move on to the database connection and setup. Okay. To make this work, the first step was setting up the connection between Python and Oracle SQL. This was done by using a library in Python called CX Oracle. This part of the code helps establish a reliable connection to the database so that Python can send SQL commands and then receive results. One thing I had to keep in mind was dealing with tables that might already exist. So since I will be running this code again and again to debug, I have to make sure that I don't create I don't run into the error of the name error where I try to create the same table again and again. So to handle this, I use the drop table statement before creating tables to avoid errors like the ORA-00955. This way I could run my code multiple times without interruption. Here, this code snippet tells you all you need to know about the establishing the connection between the Oracle and then Oracle database and then the Python. Okay, and then moving on, the table creation. This table creation is necessary because this is the only way to make sure that the tables are there in the database, which is a given. I design tables for books, authors, publishers, and so on to make sure each had a primary key, proper relationship through foreign keys. For instance, the customer order table links to the customer table showing who placed the order. This structure reflects the relationship from the AR diagram and ensures that everything is connected. So this is the basic SQL queries that is being executed using the cursor dot execute function, which is a dot function which is got from the CX Oracle library that we use to establish the connection between the Oracle SQL and then the uh, uh, Python. Okay, so this is example code snippet that is used for the this is the book table, and then now let's see this code into great detail. This, as I said while explaining the ER diagram before, this book table has several entities, several attributes like ISBN, title, publication year, price, and then the publisher ID, which is referenced as the foreign key from the publisher table, and then total sales. Now, looking at the varchar2, this is the type of the ISBN, which I say to be a variable character, and then I set the length to be 20, and then I say that this should be the primary key in this particular table, and then talking about the title, I say this should be a variable character of length 255. And then the publication year. This publication year is just a number, and then the price number. It is of length 10, and then of decimal points of up to 2 decimal places. And then the publisher ID is obviously a number, and then the total sales is also a number, as I said before, 10 with 2 decimal places. And then the coming to the author table. Author table also has author ID, and then I say this to be the primary key of this particular set. So I in this method I make sure that every table is created without having any errors, and primary keys are defined as and when the table is being created, so I don't have to run into trouble of having to deal with the issue of having I mean, like, data redundancy. That doesn't happen. So now let's move on to data insertion. So now that the tables are created, all it needs is just the data in that, so that we can play with that. Okay. It was as I said, once the tables were set up, it was time to populate them with the data. I inserted about 10 to 15 records into each table to create a realistic data set. So, for example, the the book table has entries like Harry Potter and the Philosopher's Stone, which is one of my favorite books. And then with this ISBN, publication, blah blah blah, those things that I mentioned that has to be there in the table when I created the table. And then this sample data is essential for testing queries and analyzing database structure. One thing I had to keep in mind was that I plan on using every data that I insert with the query, and then test it with the query. Okay. Now it helped to simulate how the system will perform with real world data. So I not only inserted data, I also made sure that the data was near real value. Like I didn't just insert ABC. I inserted a real book's name, and then the real year that it was published, and then the price of it in current market, and then everything that should work, that has to work, so I can test it with real life scenarios. So let's dive into the code here as well. So I first create a list where I have every the data that I need in a set, and then this is the ISBN, the title, and then so on. So moving on, this for book and books. This is the loop that executes the cursor.execute function from the CX Oracle library that I had installed to establish the connection between Python and the Oracle SQL. So this iterates to the books list that I created. Then this is just a simple way to reduce the number of lines in the code. So this iterates. So you can see here 1, 2, 3, 4, 5. So this iterates through it, and then and this is the let's use the word skeleton. The skeleton of the SQL query that I need to work to insert them into the table. So this query, this loop iterates, and each and every data is being inserted. Uh, so uh, in the initial phase of testing, I had to make sure that every data is being inserted properly. So every now and then when I insert the data records, I make sure that I check it once again by printing the printing all the columns and all the columns and rows, so that the data is not lost, and to make sure that I'm going in the right way. So now let's move on to the actual okay, the Python integration and the output formatting. Oh yeah, output formatting was one of the major things that I had to deal. So this was not how it was printed. So you are seeing the photo. This was not how it was printed earlier when I tried first time. So I had to use this tabulate library that I found out to make sure that it is quite readable. So yeah, there are many other ways. So we can use the pandas library as well. But I thought the tablet was much simpler than pandas, so I went with that. Um, Okay. So integrating Python made this project more dynamic. Python is a simple language, and it is easy to learn. So integrating Python with Oracle SQL had to be one of the had to be one of the things that I had to do to ensure that I will be able to tackle any such problem that I will be encountering in the future. So I use CX Oracle, as I said before, to execute SQL commands directly from Python, which made tasks like inserting data or running queries much simpler. To make sure the output was easy to read, I used the tablet library, as I said before, to format query results. So as you can see here, this is the formatted output that I got from the tablet library. Okay. This means that when I ran a select query, the results were displayed in a nice organized table, making it easy to read, see, and understand. So as you can see, this got me the result that I needed. Now let's move on to the queries. Okay, I the objective of my project was to run 10 different DDL and DML queries in SQL. So I had to make sure that I run these 10 queries in my project. The first query is a DDL statement where I added a new column called number of pages to the book table using alter table. This type of query is useful for extending the database schema when adding when additional information needs to be captured in the future. So we never know when we need additional information. For example, there may be a new scenario coming in the next 6 months where we don't know that we didn't know that we needed that. So as and when we are encountering the problems, we need to make sure that we can solve them as well. So moving on to the second query. The second query is a DML operation where I updated the biography of a specific author in the author table. This kind of update helps keep data current and relevant. In this case, I modified the biography of George Orwell to provide more context about his work and social critique. Okay, now moving on to the third query. I ran a select query to find all the books published after the year 2000. This query is essential for filtering out modern publications, allowing the bookstore to focus on recent releases for promotional activities or special events. This may also be useful when there is a filter function that is being applied when I create let's say a e-commerce website, and I have to add a filter tag and then show only the books that have been published after the year 2000. So this SQL query will be useful there as well. The query number 4. I executed an aggregation query to count the number of reviews with a 5-star rating. This is a particularly valuable for analyzing the customer feedback and understanding which books are top rated. And moving on, this can also be used when I need to make sure that I have some type of algorithm for recommendation in the said e-commerce website. So I run this query to just get a check on myself. And then the query number 5. This query involved a join operation to list books along with their publishers. Um, by combining data from book, publishers, and publisher tables. So this was performed by using a join operation. So I selected the title and name from book, and then joins on publishers by the foreign key in both the ISBN, and then the publisher P, um, which I joined using the publisher ID in both tables, which is referenced as the primary key and foreign key in the other table. Now moving on to the 6th query. I updated the price of a specific book to reflect changes in the market. This type of query is used to ensure that book source pricing is up to date. So during this inflation season, there will be changes in prices, and then the author may want to get a much higher market. So that may happen. So in that case, I have to make sure that everything is noted. So the query number 7. The 7th query calculates the total number of books included in a specific order identified by order ID. Okay. This is useful for inventory management. Help the store track how many units are involved in each store. Now moving on to the 8th query. This query identifies authors who have written more than one book. It highlights prolific authors and can inform marketing strategies that promotes their books as a collection or series. And then the 9th query. The 9th query is a DML operation where I deleted a specific review identified by review ID. Okay. This operation is essential for maintaining the integrity of customer feedback, especially when dealing with the inappropriate and incorrect reviews. This will be a major thing when the e-commerce website, in the e-commerce website. So yeah. Moving on to the query number 10. Finally, the last query lists all the customers who have placed at least one order. This query helps the bookstore understand its active customer and can be used for target promotions and or customer loyalty. So these people can be targeted and then sold more books that they have bought, and then suggested some books like the previous one. Now moving on. Moving on to the final part of the presentation, challenges and solutions. There were some challenges during this project. The most common one was handling the ORA-00955 error. This occurs when the table already exists, and then you try to create the table, another table with the same name. So I just went to Stack Overflow. I found that this occurs, and then found the root cause. And then to tackle this problem, I added a drop table segment before table creation, so that every time I run the code, the existing tables are deleted and then created. But this is not efficient. I know that. So this is just for this basic implementation stage. And then formatting output was another challenge. But using tablet library helped display results neatly, and which improved the user experience significantly. And then finally, the key takeaways and future enhancements. This project was valuable learning experience. I learned how to build a database from the ground up and add more features like stored procedures and a user-friendly web interface or easier data. As I said, the e-commerce website is still on the table. And then the conclusion, finally. Thank you. Before we wrap up, there's just one more thing that you guys have to see. The code execution. Let's just dive right into that. This is the code that I typed. So I'll run this once again just to make sure that everything works. Hopefully there's no errors now. I'll just open the console so that I see the output. So yeah, this is the output. So query number 1, order table has been successfully executed, and update it has been also successfully executed. And then since there is no, I think I made a mistake entering, so no results are being found, which is quite correct. And then the select found So this is what I meant by using tablet library, and then yeah, query 6, 7, 8, 9, and then 10. Yeah, that's about it. So yeah, thank you guys. Thank you for watching. Yeah. Oh yeah, switch purpose. Thank you very much.